I want to go into a little bit more detail of each of the different kinds of loops, and so I've written just a little bit of code here for starters so that I can quickly just go through some examples and explain the details of these examples. I've created an array of integers of size 15. I've created an array list of integers. I wrote a method called fillRandom, and I pass it my array. And it will fill that array with random numbers. So each time I run this, I'll get different numbers. I've created another fillRandom method that takes an array list and a count. And it'll add that number of things to the array list. And it's basically just filling the array list up with random numbers. So that I just want to show the differences a little bit between arrays and array lists. I've created a print array method because, as we've seen, arrays are a little bit more tricky to print than just an array list. And so this way I can just, after modifying stuff, I can just print it out again conveniently by saying print array and pass it the array. And then I've also this just prints the array list. So if I just run this real quick, you'll see the first thing I printed was the array, the second thing was the array list, and they're just filled up with random numbers. A quick glance at those two methods, well, three methods. That's fillRandom, that's the other fillRandom, and that's the print array. I may go through those in a little bit more detail later, but let's just understand what they do, and then let's look at the different kinds of loops. The first one that I want to look at is really the easiest. It's what's called a for each loop, and for each loops work exactly the same way on arrays as they do array lists. And the way to think about it is these are convenient and really easy to use if you want to do the exact same thing on every element of the array or list. So you say for, open round bracket, and then if it is an array of a particular type, well, it is always an array of a particular type, but you put the type that the array is holding. So in this case, my array is holding integers. I chose objects because it's a little bit easier, although it is less efficient. I may change it to basic data types, although then I'll have to maybe rewrite my print array method a little bit. But anyway, so I'm going to say for each integer, I'll say A, that's contained in, so I'm using a colon, that's contained in my array. I want to do something to that integer object. Let's use this to calculate the sum. I'm going to say int sum equals 0. And then I just want to add the value of that to sum. So I can say sum plus equals A. And then I can say system dot out dot println sum. And if I run this, the sum is 172. Okay, now this is a big array. I'm just going to make this thing a little bit smaller. And I'm going to say, 4 items. And then run it. And did it add up those 4 items? There's a 20, a 19, a 16, and a 7. So, and it's saying that's 62. Let's see. 19 and 16, I can do that fairly easily. That's 35. And plus 20 would make it 55, and 2 more is 62. So sure enough, it works. So that's a for each loop. For each loops work just fine on arrays or array lists. Now, let's fill our random array with just 4 things. And let's reset sum to 0 and say for each integer A contained in my array list sum plus equals A, and then system.out.println sum again. If we run this, we get, for the bottom one is the array list, the top one is the array, because up here I can say, okay, I printed the array, and then I printed the array list. I calculated the sum of all the elements in the array and printed that out. And I calculated the sum of every element in the array list and printed that out. So 15 plus 16, that's 31, plus 8, there's not 39. Yeah, it is. Okay. So that's working. That's good. So what is a limitation of a for each loop? A for each loop cannot modify the original array. So say I wanted to do something like, okay, now I want to make a little note here. I did these little one-line for loops. I did not use any squiggly brackets. Now I can get away with that because there was just one instruction that I wanted to do inside the for loop. If I have more than one instruction, I have to add squiggly brackets. So I'm going to just go ahead and do that. And most people think it's better form, a better habit, a better practice, to always put the squiggly brackets. What if I want to remove anything that's bigger than, say, 10? Okay? I cannot do that in a for each loop. I could write code that says if A is greater than 10, my array list dot remove A. And it'll compile, and it'll run, but it'll probably crash. And the error we get is what's called a concurrent modification exception. So what's wrong here? The problem is that this for loop is going to try and go through and edit every item of the original list. But as soon as it removes one, it shifts everything else in the list. And then it it just messes up the next iteration of the list. So we cannot modify this original array or array list inside of a for each loop. So what if I do want to remove every item that's bigger than something? So if I have a loop that performs an action that requires the modification of the original container, I need a regular for loop. And anything I can do in a for each loop, I can do in a regular for loop. So what if I say something like for int I equals 0, I less than my array list dot size I plus plus. Now I want to get an element out of the list, so I say integer A equals my array list dot get at index I. So the way this works is I is going to start out at 0. It's going to get the thing at index 0. It's going to do the action, and then it's going to do the thing at index 1. Now I've got a little issue here, and we'll see it in a second. But I can add the line if A is greater than 10, my ArrayList.remove A. And it's almost good. It will certainly, it won't crash. I'm going to comment out this code so that we get rid of that crash. Otherwise, I can't run my new code. And I didn't print it out a second time, so we can't see what it did. So let's, I'm going to get rid of some of these other print statements. I'm just going to get rid of all that code. And I'm going to say system .out.println my array list. So this was the original 0, 10, 15, and 12. And I got 0, 10, 12. It removed the 15. Now 10 is not greater than or equal, or I'm sorry, 10 is not greater than 10. It's equal to. So let's say I want to remove every two-digit number, but why didn't it get the 12? Well, what happens is whenever you remove an item, everything is shifted left. So let me do this a little bit in Paint, and let me erase some of this stuff. Okay, so the first time through the loop, so when this loop runs, the very first thing it does is it executes this statement. It creates the variable I and sets it equal to 0. And so we have the variable I up here, and it's holding a 0. And then it says I less than myArrayList.size. So what's the size of the array? Well, it's got 1, 2, 3, 4 things in it. So 0 is less than 4. That evaluates to true. So it evaluates the expression between the semicolons, and then it performs this instructions between the squiggly brackets. So the first thing it's going to do is say it's going to get the thing from I. Okay, myArrayList.getI. And so myArrayList is a variable that points to an array list in memory, and it's got in it pointers to these different integer objects. And if it's going to get the thing at index I, well, the thing at index I, since I is 0, the thing at index 0 is this integer with the value of 0. See, this is the array list, 0, 10, 15, and 12. And so it's going to take that value of 0, that integer with the 0 value, and it's going to store that in the variable A. So actually, what is happening here is the variable A is now going to have a pointer to the integer 0, the very same integer object that is in the array. And then it says, if A is greater than 10. So the 0 is not greater than 10, so that evaluates to false. So it's not going to remove, it just goes in I plus pluses. So I is now 1. After adding the 1 to I, it comes back around and tests the expression again, and 1 is not less than the size, or is less than the size. 1 is less than 4. So it's going to execute the instructions inside the loop. So it's going to get the thing at index I. That thing at index I is this object here, because I is 1. That thing there is 10. It's going to assign that value to A. And so A is now going to point to the 10. So A is pointing to the 10. It's going to evaluate if A is greater than 10, and 10 is not greater than 10, so at I++, and it'll check again. So I changed from 1 to 2, and 2 is still less than 4, so it's going to perform the next instruction, and so it's going to get the thing at index 2 and assign it to A. A now points to the 15, and 15 is greater than 10, so it's going to remove A from the list. So when it removes that item from the list, it's going to remove that item and then shift the other items to the left. So anything that comes after it gets moved. Now it is interesting to note that the 15 is removed from the list, but A is still pointing to it. The 15 still exists in memory. But when you remove 12 from the list, then the stuff that comes after it, well, there's now only 3 items in the list. Okay, everything that comes after the 15 is shifted left. And then we I++. So we just removed the element from the list. We add 1 to I. I was 2, we add 1, it becomes 3. And now we test. We say, is I less than the size of the array? Now that we have removed an item, the size is no longer 4, it is now 3. And I is not less than 3, so we exit the loop. We never tested 12. When it got shifted left and I gets incremented, we end up skipping over it. So whenever we remove an item, we end up skipping over the item that comes right after it. That's a problem. So let's fix it. So for this if statement, I did the same lazy thing where I only had 1 instruction, so I just stuck it right there and left out the squiggly brackets. I want to add another instruction inside of the if statement, so I'm just going to add a squiggly bracket. I hit enter, and it brings me down to the next line, and Eclipse already automatically adds the next squiggly bracket. Whenever I remove something, I'm just going to go ahead and I minus minus. And so now if I run this, and I'm going to make it a little bit bigger array list. So instead of just adding 4 items, I'm going to add 14 items in the beginning. I'm going to fill it with 14 random integers. Okay, so this was the array list of 14 random integers, and that for loop should have removed anything that's greater than 10. So 15 is greater than 10, 13, 21, 11, 14, 21 are all greater than 10. 6 is not. 6 was left in the array list. 4 is not. 4 is left in the array list. 18 and 18 are both bigger, but the zeros, they're not bigger than 10, so they're left in the array list, and 21s are removed. Okay? So we've seen 2 types of loops, 2 types of for loops. A for each loop that goes through every element in the array. A regular for loop that can go through the elements but can also modify the original array. Now I want to make a special note that it's not just about removing items and adding items. I can't move anything around inside the array. I cannot modify so this is holding objects. I could not make this element point to a different object if I'm in a for each loop. I have to have a regular for loop if I want to modify the original list, okay, or array. for each loops are good if I want to do exactly the same thing to every item in the list. But they do not allow me to modify the original list. Okay, and a while loop. What is a while loop for? So what I will usually use a while loop for is if I don't know how many iterations I'm going to go through. If I don't have a good initialization value and I don't have a nice increment, okay? So a regular for loop is great for walking through an array. But there are things that it's just, it's just not always the most convenient constructs. Now, anything that I can do with a regular for loop, I can also do with a while loop. So how will I use a while loop? Well, if I want to do something like reading input until I get a certain condition. So let's say I want to calculate a total and keep adding numbers together until I eventually reach a certain limit, right? So I'm going to say int limit is equal to, I don't know, 55. And then I'm going to say int total is equal to 0. Now I'm going to say while limit is less than the total. Oh, I'm sorry, well, the total is less than the limit. Okay, originally I was thinking I was going to read from input, but on second thought, I think I'd like to try to keep it a little simpler than that, and not have to add the extra complexity of reading input from the command line. I want to count how many times it takes me to double a number before I exceed some other number. So I'm just going to say limit and limit other number. I'm just going to say number 1. First, second, and count. So let's say my first number is 3, my second number is 1,000. And I'm going to count how many times I'm going to double this first number before it exceeds the second, okay? So while the first is less than the second, first times equals 2, and count plus plus, okay? Count plus plus just adds 1 to count. And then system dot out dot println count equals plus count. We'll run this. And it took 9 times to double 3 until I reached 1,000. This may not be exactly the best example of a while loop, but I think you get the idea. I didn't necessarily know how many times I was going to go through the loop. So it makes some sense, although we could have written it I could not have made it a for loop and put count on the inside. So it's tempting to say for and then count, int count equals 0, first less than second, and then count plus plus. It would be tempting to do something like that, but I think it'll print 0 Actually, it won't even compile. It's complaining. It's complaining because I have a count out here and a count in here. So let's get rid of this one. And it's not going to, well, now it's going to complain that it doesn't know what count is out here, because count is declared inside the for loop, and then this count doesn't live outside. So if you want your variables to live beyond the for loop, you have to declare them outside of the for loop. So a while loop kind of works a little bit better, a lot better for this particular example. A do while loop. Okay, so the way a while loop, it's a little bit simpler construct than a regular for loop. It's just got a condition. And as long as that condition remains true, it does the things between the squiggly brackets. A do while, do something while, okay. So the idea here is it's very much like a while loop, except that instead of evaluating the expression before entering the loop, it evaluates this expression after doing the loop. The only advantage of this is that it ensures that you will always go into the loop at least once, because the first time through the loop it's guaranteed to go in. And then it's only going to go around the loop a second time if the expression is true afterwards. So these are fairly rare, but every once in a while you see an occasion where inside the loop you want to guarantee that you go into it at least once. I'm not going to execute that. An iterator loop. I think I'm just going to skip iterators. No, it's on the quiz. I better not skip the iterator. So an iterator it's a faster thing. It's about speed and efficiency. It works similarly to the for each loop, except that it's and it has all the limitations of a for each loop. You cannot modify the container inside of a for each loop. You can use a for each loop on an array or an array list, but you can only use an iterator on an array list. You cannot use it on an array. So let's say I want to find the maximum element in a list. I'm going to say something like iterator it is equal to my array list dot iterator. Okay, so this creates an object. And I'm going to have to import so I got to spell it right, iterator, and make sure that it's imported. Now I want to do something like while it dot has next. Whoops, has next is a method. I'm going to say integer max. I'm going to start it out as null. Null is just an address to nothing. While the iterator has something else, I want to say if max equals, well, let's just say something like integer a equals it dot next. Get the next element out of the iterator. What does it not like about that? Ah. It's got to be an iterator of integers. Okay, so now if max is equal to null, go ahead and let max equal a. If a is bigger than max, then max equals a. And then I can say system.out.println max. And this should find the biggest element in the list. So is 8 the biggest thing in the list? 4, 8, 8, 4, 5, 5, 4. See, I've removed everything that's bigger than 10. So this thing should always be 10 or less, no matter what. And yes, it found the biggest one. So the idea of an iterator is it's grabbing each element out in order. But I could not remove or add stuff to the array list while I'm iterating through it. That would cause a crash.